Okay, folks. So we're gonna look at the this flipped classroom here. How did I get these answers? So first off, let's see, BAS HF FeCl3 and SnO2. First off, it's always about classifying these guys. If you can't classify them correctly, how are you supposed to even name these guys? So covalent / molecular is one class, ionic is another, and acid. So covalent / molecular, the first atom is a nonmetal. Ionic, the first atom is usually charged, typically a metal, and acid, the first element is is hydrogen. So being able to recognize that, we can usually get bored. So this guy, first one, is a covalent / molecular. I do not want the common name. What I do want is how we name molecular binary compounds, which is first element just gets the name. If there is no subscript, it does not get a prefix. So we assume this to be 1. This guy is anyone's guess, so we must always give it the prefix. So there's 1, so it's monoxide. Oxygen gets turned into oxide. Now, barium is a metal, so this is going to be ionic. Barium is group 2, so it is not a transition metal. We don't have to label it. It just gets its name, barium. Well, sulfur needs to be turned into sulfide. Anytime it's the pure element or one of the special compounds, it's just going to get the normal IDE ending. This guy, it's an acid. So we're going to look to how would we name this to help us figure out how do we name the acid. This guy would be fluoride. So this becomes, whenever there's an IDE, the fluoride gets turned into hydrofluoric acid. We have changed a prefix and a suffix because of the IDE. Back to a metal. This metal is so it's ionic compound. Specifically, iron is a transition metal. So this would be iron chloride, but specifically we need to label the charge of this transition metal. So to do this, we have to look at chlorine. Chlorine is group 7A. To get to 8, it needs to gain 1 electron. Because there's 3 of them, the total negative charge of all the anions is -3. Meaning the total charge of all the cations is +3. So since there's 1 iron, that 1 iron must be +3. So we call this iron 3 chloride. Looking at this one, it's ionic. Sn, it's not selenium, it is tin. Tin is a transition metal. I know it's not in the normal transition metal region, but it is a transition metal. Everywhere on that periodic table below the metalloids is a transition metal. So this is tin. Oxygen becomes oxide. Now, because it's a transition metal, we must label the charge. Oxygen is group 6A. To get to 8, it has to gain 2 minus. Now, because there's 2 of them, the total negative charge of all of these is -4. -4. So that means all the cations must be +4. Of course, that means since there's one tin, it is tin 4 oxide. So let's do the next set. KNO3, NH4, 2SO4, SCl6, HiO2, and CaCO3. Okay, looking at these now. Once again, it all comes down to classifying these guys. K, that's a metal, so this is ionic. K is potassium. Potassium. Now, here's where it gets a little bit harder. NO3, that is not nitrogen trioxide. No, it is an oxyanion. Oxyanion. It's an anion that is created when we add a bunch of oxygens to a metal or non-metal. We label this based on the first element in this oxyanion, the nitrogen. Then we give it an ending that reflects how many oxygens it contains. So the first element is nitrogen, so it's a nitra. And we give it the ending because 3 oxygens is nitrogen's max, so nitrate. Potassium nitrate. Now this is the one major exception. This is ionic. This is you have to learn this cation, but this is ammonium. Ammonium. Once you recognize that it's ionic, it just becomes ammonium. Now we have an oxyanion. The element here, sulfur, so it's going to get a sulf. And 4 oxygens are sulfur's max. 4 oxygens, so this becomes sulfate. Ammonium sulfate. Now, back here. So sulfur is a nonmetal. So this is a covalent molecular structure. So the first guy, sulfur. Then we have to label how many chlorines. Hexachloride. Following up, this is an acid. This is an acid. So I look at what is this? IO2 is a oxyanion. It is specifically iodite. So iodite, when it becomes an acid, every time you have an ITE becomes OUS. So this becomes iodous acid. Iodous acid. And then lastly, for this column, it's a ionic compound because of calcium. Calcium is group 2, so it's just calcium. And CO3 is a oxyanion. It's carbon, so carbon. 3 oxygens is the max for carbon, so carbonate. Carbonate. So, kind of running out of room, so we'll work it from down here. H3PO4, BeOH2, HC2H3O2, LiHSO3, and PF5. So, okay, let's see. Now, starting right here. It's an acid. We don't refer to how many these are because it's already assumed. So we look at this. PO4 is phosphate. Anytime there's an ATE, it becomes ic acid. So phos 4 ic acid. This is ionic. So just say, what is this? This is beryllium. And what is this group? This is a special group. This is hydroxide. Hydroxide. The next one is another acid. However, this is a very weird functional group. The C2H3O2 minus is acetate. So with that, anything that ends with an ATE becomes the ic acid. So acetate becomes acetic acid. Now the second to last one, I know there's an H, but there is a metal. So it is named like an ion, not like a acid. So it becomes lithium. Now because there's a hydrogen, we have to reference the hydrogen. Hydrogen. Now SO4 is sulfate. So SO3 is sulfite. I would also accept lithium bisulfite. Probably prefer this one, but will not mark off for that one. Lastly, this is another covalent molecular compound. So phos for us. What's 5? 5 is penta. Pentafluoride. Pentafluoride. So there we go. I know it's not much. I know it's fast. But that is the flipped classroom, how I would go about each one. Now, some of these you kind of have to learn the patterns, and it takes a while. Some of these you have to learn the formula. Like, I can't tell you how to get acetate other than you kind of memorize acetate. But once you get it down, it's like, I don't know how I ever didn't know acetate. So it's a matter of memorizing it for that first time. Okay, that's all.